Okay, so let's solve this question. The question states that consider the finite state machine FSM with one input X and one output F. So this is the input. These are the inputs, right? And these are corresponding outputs that would exist, right? And input and these are corresponding outputs represented by the state transition table. So this is the state transition table presented to us. The minimum number of states required to realize the FSM is. So what is the minimum number of states, right, that is going to be realized? So the number of states which are presented over here are basically 4 here, 4 here, right? So 4 here, 4 here, totaling to total 8. So the answer over here would be from 0, not 0, 1 has to be present, 1 till 8, right? That kind of thing would be present. So this is obviously a numerical answer type question, so there is not going to be any negative marking. So from this analysis only, you must mention a number between 1 to 8 because there is not going to be negative now. So why basically take the risk? But obviously, how can you simplify it further, right? By bare observation, this kind of machine in which the basically outputs are defined for every single transition, right, from A till F or A to B transition for the given inputs of these kind of inputs being present, the resultant outputs are defined, right? So the outputs are dependent upon the transitions, right, are dependent upon the transitions, and hence, and not the state. If it were to be dependent upon the state, this would have been a Moore machine, but because the output is dependent upon the transition, so it is a Mealy machine. But being a Mealy or Moore, that nomenclature is not important. The actual funda of FSM is that for any state, the definitional component is the transitions that the outgoing transitions are the definitional component for every state, right? So if this is, for example, this is a state, right, the incoming transitions are not really very important in defining that particular state, but the outgoing transitions are which are important in defining the state, right? So if two states have exactly same outgoing transitions, then those two states are going to be the same. That is what basically it means, that the outgoing transitions are important in defining the states, right? So with that part being very clear to us, let's try to solve this thing by means of seeing the entries and then deducing what are the entries which are same, right? So the outgoing transition is defined completely by this entry, right? So if any two of these entries are going to be the same, then those two states are going to be the same, right? So let's go with that. So first let's consider this. Is there anyone anywhere over here that has F and B? Not this one, not this one, not this one, not this one, this one, yes, right? And the output is 1 and 1, and here 0 and 0 is used. So this is, the first part is same, but the output is different, right? But because it is the output is also part of the transitions, right? So it is a different entry. Okay, then is F and B present over here? No. So this A is basically different than every other one. Now DC, is DC present in any other place, right? So DC is, let's consider it DC, we're considering DC. So DC present over here? No. DC present over here? No. DC present over here? Yes. Is the output same? 0 0, output is also same. Very good. So this entry, E entry, is basically same to your B entry. Is there any other DC? Not really. So we can say very clearly that B is equals to E, right? B is equals to E, and because B is from an alphabetical point of view, B is a bigger alphabet, right? Alphabet which comes with a basically dictionary index of greater than B. So we can basically change every single entry entry of E to B, right? And then simplify from there, right? So this is one thing that we got. Let's go back and just cut the entry for E and change every single E to B, right? Every single E to B. Is there any other E? Not really, right? Now we will go from the starting one again because B has been introduced, right? So FB over here, is there any other entry with FB? Yeah, C has an entry with FB, and this entry is still different, but this entry is same as your A. So from this we get that A is equals to C, right? So I'm going to cut this entry and I'm going to change every single C over here till A to A, C over here to A, and there is basically no other C. So these are the only things that are present. Now let's look from the starting one more time. FB is not really any other. This one output is different. DA is any entry of DA sort present? Not really. GA, okay, GA10 and GA is present over here. GA, this one is common to this one, right? So D is equals to H, and H entry can be cut. Every single H can be changed back to D. Any other D, any other H in the whole thing? Not really. Now this GD, any place GD present? Not really, right? So these three entries are basically the common ones, and these three are basically cut out from the diagram. Total there were 8 entries. Now minus 3 if we do, we get 5, right? So the answer for this particular question is going to be 5. Yeah, the basic funda that we used over here is basically that that a state's definition depends upon its outgoing transitions, right? And from that definition we did the simplification. Obviously I have the benefit of the computer with me, while you have to do this with rough paper and all. Obviously do not write the whole of transition table every single time. Just write that B is equals to E at every single entry, and once you have this entry, then in your mind interpret every single E as B, and then from that simplify, right? Then from that simplify, and if you look at the entries which have a bigger alphabetical order symbols, just do not look at them, right? Once you have basically concluded that E is equals to B, then do not read the entry for E again, right? That kind of way you have to interpret the question, right? With your imagination and with your rough paper, writing this part down, right? So it's focus, imagination and practice that is going to be required for you to solve this question and get to the answer 5 in a reasonable amount of time, so as to score well in GATE, right? I hope that you were able to solve this question by yourself, and this video only serves a validation. And with that, I hope you a very good day, and I will meet you in the next video.